Okay. So good evening guys. So in last class we have started with laws of motion, right? So we have completed up to what is normal and what is the weight, and we have seen some diagram where the normal force will act and how the normal force will act and how the weight will act. So now we will go for the problems here. Suppose if I take if I take mass m1 and there is a mass m2. Now I am applying a force over here, right? Now I am applying a force over here which is nothing but F. Okay, and I need to find what is the acceleration of the blocks. I need to find what is the acceleration of the block, how much acceleration it has been going. Okay, so to find that, first I need to find what is the forces are acting in mass 1 and mass 2, right? Now, so let me take a free body diagram for this first. So for the mass 1, what are the forces are available? One is external force, that is F, right now, and one more is weight, that is m1g, and one more is the normal for the block n1. Okay, and the block m2 is having a surface with m1 and m1 is having a surface with m2, which means there is one more normal will be in this direction, right now. So this is n I will take. So now if I consider now this is my surface, n1 should be equals to m1, right? Now it always should be equal, then only the block will go according to the surface. If it is not equal, no, it will hang. Yes, no? Yeah. So this is my direction, right? This is the free body diagram of m1. Let me take the free body diagram of m2, which is there is a normal force exerted by mass 1 will be in this direction. No, whatever the normal force will be in this direction, exact normal force will be for m2 also, right? Now this is my n. Am I correct? Now there is one more normal force, this is n2 and this is m2g. So that's it, there is no other forces are acting and the block is going in this direction, right? So let me give a simple trick to find over here. Wait a minute, I'll arrange the camera. Yes, so let me give a simple trick. So first find the free body diagram and what are the forces are available and write down the acceleration. Okay, give an acceleration. Now whatever the direction of acceleration is there, in that direction whatever the forces are there, no, take it as positive. Okay, and opposite direction of acceleration forces are negative, right? No, so let me write like this. No, so what is the forces are available in this direction for m1? Only F, so which should be in positive. So n is in the opposite direction, which is negative, should be equals to, okay, the mass of the block and the acceleration, which is nothing but m1a. Got it? So it is my equation number 1. Let me write the equation for this also. So this is my positive thing in the direction of acceleration, which means n should be equals to m2a. That's it, m2a. This is my equation 2. So if can I add these two equation? So n minus n and n will get cancelled. So F will be equals to m1 plus m2 of a, where a will be equals to force by the total mass of the system, m1 plus m2. So this is my acceleration for 2 blocks. Okay, so when we are having a 3 blocks, no, like if I consider one more block over here, I need to draw one more free body diagram. I will have one more equation further. Okay, so first you can copy down this one and we'll go for the next diagram.
the blocks together.
Yes. So it should go together, no? So which means a force should be there, equal and opposite force should be there. That is internal force, we will say. So now either we can say it's a normal force between these blocks, or else we can say it's an internal force. So internal force in the sense like whatever the forces are acting by M2 should be equal to whatever the forces are acting by M1. Then only it will go together. If it is not equal, it will separate. Completed. We'll go for the next one. Done, right? So when I consider a block of 3 or 4, we'll see what will be the acceleration for that. Yes. So let me take up blocks M1, then M2, then M3. Okay. Now for this case I will take a force which is acting in this direction. Got it? So let me take from this side where the force is starting, that side I will take. Okay. So which means let me consider the first one as M3, right? No, M3. Now the force is acting in this direction, no, F. So before that I will assume the direction of acceleration will be in this direction. Now if I push the objects in this direction, it will come like this. So acceleration of every block will be in this direction. So there will be a normal force which is exerted by M2. So will be in this direction, N. Okay. So this is my normal 3 and weight will be M3G and acceleration of block will be in this direction A. Right now. So for the next one, M2. M2 is having equal and opposite force, that is normal force will be there, which is exerted by M3, will be in this direction, right now, in this direction, which is N, and the force which is exerted by M1 also will be there, no, which is in this direction, that is N dash I will take. Okay. Now this is my N2 and this is my M2G, acceleration in this direction, that's it. Now one more thing is there, what is that? I will take you. So this is my M1. So M1 will be having a normal force, wait a minute. Yes. So normal force which is exerted by M2, that is in this direction, no, N dash. So the normal force for M1 will be N1 and it is M1G, right, no. So acceleration will be in this direction. So can I write the equation now? It is easy, no. Now we have got every forces, what are the forces are acting on the each blocks. Okay. Now if I see here, object is moving in the x axis only. So I need to consider only in the x equilibrium conditions, right, no. So what is the thing I should do now here? So first object I will take object V. Okay. So force is in this direction. If I see the acceleration also in the same direction, which means F minus N will be equals to M3A. Okay. And for this one, N minus N dash will be equals to M2A. For this one, it is N dash will be equals to M1A. So if I add everything, N and N will get cancelled, minus N dash will get cancelled. Okay, no? So what will happen? F will be equals to M1 plus M2 plus M3 of A, which is nothing but A will be equals to the force which is exerted by, external force by the total mass of the system, M1 plus M2 plus M3. Got it? Take it. right now. So we'll go into the deep of the problem in the upcoming slides, okay, when we start doing the equilibrium condition. So just now I have given the rough idea about the equilibrium, okay. So we'll see what is the tension first and what is the friction, and then we'll go for the next topic, okay. Yes. So now the tension. So denoted by the letter T, okay. So we have completed a normal force and the weight. So normal will be perpendicular to the surface, okay, and weight will be acting towards down, right now. Now the tension thing. So whenever we are talking about the tension, so the point will be either it is in string or rope, okay. A rope is there, an object is holding in both the ropes. So what will be the tension? Like you have seen the pulleys, no, in the well to take the water out, right now. In that, like one rope will be down and one rope will be in our hand. We'll apply some force and the water will come up. So in that cases the tension will be acting over there, okay. So here if I take those pulleys condition, no, so this is my pulley, so which is like this, like it's a massless pulley, okay. So one object is hanging like this, this is M1, and one more object is hanging like this is M2, okay. So when we are talking about the tension, no, it is always acting away from the body. So first one normal, perpendicular to the surface, W like weight is acting towards the center or towards down, okay, towards the center will write, okay, and tension is it's acting away from the body, which means if I consider this is my weight, no, let me take a free body diagram. So this is my M1, so tension will be acting away from the body. One more weight is there, that is M1G, like one more force is M1G. So whenever I consider a body, no, there will be a weight obviously, right, no. So one more thing, here it's a contact. So contact with the rope or string, anything, the tension will be there. Contact with another surface means a normal will be there, okay. So this is my T and this is my M1G. So what will be the free body diagram for M2? Similar thing, same, it is away from the body, this is my M2, this is M2G, and tension will be away from the body, okay. So keep in mind a note point, same string or rope, same tension. Different rope, different tension. Done. So this is the main point. Like when I talk about this point to this point, no, it is connected with a single rope, right? No, single rope means same tension will be there. Whatever the tension acting in this point will be acting in this point also. If I consider from this point to this point, it's like let me consider point A and point B. From point A to B, the tension will be same. Okay. If rope changes, no, tension changes. Done. So when we talk about a rope, no, a pulley, we have free body diagram. When we are talking about a diagram like this, a normal force is there. When I connect with the rope, so how will be the equations? We'll see. How will be the diagram? We'll see. Okay. So let me take a diagram like this. So there is some mass m1 connected with one rope. This is mass m2. First, let me take a free body diagram for the two blocks. So now force has been applied in this direction. Let me consider. Okay, I have pulled the object like this. What will happen? Object will go in this direction. This is my acceleration, right? Now the free body diagram. So let me take a free body diagram for m2 first. So m2 will be having a force, that is F. Okay, and how will be the tension acting? Away from the body. So tension away from the body, in the sense it is the tension away from the body. So which means this is my T. Okay, so acceleration is in this direction. So as of now we will talk about the forces, like only free body diagrams. Okay, so next one, the object m1, no. So m1, in the sense, in this point only the rope has been connected. So which means a tension will be in this direction, like away from the body. Away from the body, no. So this is away from the body, and for this also away from the body. Object is going in this direction, A. Okay. Instead of a contact, no, a normal was there. So now the rope is there, tension is there. That's it. Okay. So now if I talk about mass 1 connected with one rope, that is m2. Okay, another rope I will take, and this is my m3, and a force has been applied now. Okay, now if I notice here, no, for m1 and m2 there is one rope, and m3 and m2 and m3 and different rope is there. I can't take T here and T here. Yes, no, I should take different T. Like different tensions will be acting over there, because it can be same, it may not be same also, like masses, right? No, so if I consider mass 1, no, or m3 I will consider first. m3, okay, forces in this direction, tension will be in this direction. This is T, and this is my F. Object will be going in this direction, no, A, right? No, so when I talk about m2, this is my tension T, and different tension, this is my T1. Okay, or let me consider this is rope 1 and this is rope 2. So T1, this is T2. Okay, no. So what about the M1 now? M1 will be having a tension away from the body in the right direction, right? No, so this is my T2. So acceleration direction, and this one is acceleration direction. So remaining, if whatever the forces are in y axis, that also I can write now. So this is my normal 3, and this is my m3g, that is weight, and this is my normal 2, and this is my m2g, weight, and this is my normal 1, this is my m1g. Okay, take it down. Done, no? Okay. So next one we'll see the topic momentum. So momentum is nothing but it is the product of mass and velocity. So SI unit will be, when I talk about mass, no, what is the SI unit of mass? It is kg, right? No, so kg, and velocity is meter per second. So kg meter per second will be my SI unit of the momentum, and it is a vector quantity. So mass will be my scalar, no, like it's a number, that's it. Weight will be my vector. Okay, mass will be my scalar and weight will be my vector. How weight will be my vector? It will be acting towards down, I will say, no? Yes or no? So mass and weight. So momentum is a vector quantity. Now if I see the example, no, let me consider object 1 going, like object 1 is there. It's having a mass 5 kg. And object 2 is there, it is also having a mass 5 kg. But these two objects, no, having a different velocities, which is this one is 20 km per hour and this one is 100 km per hour. So which one will be having more momentum? A object which is having a same mass but different velocities. So when I consider a more velocity, momentum will be more, right? No. So in this condition, what I can analyze, momentum is directly proportional to mass as well as momentum is directly proportional to velocity. If mass increases also, momentum increases. If velocity increases also, momentum increases, right? No. So if I find momentum for the object 1, no, it is 5 into 20, which is nothing but 100 kilometer. So 100 kg kilometer per hour, no? Yes, no? So whatever it is. So I will get some value 100 here. So what will be the value of here? 5 into 100, right? No, which means 500. So when I consider the values, no, momentum 1 is less than momentum 2. So impact will be more for object 2, no? Impact will be created for object 2. So let me take an example for this. So there is a mass of a scooter which is 120 kg going with a 50 meter per second now. So momentum will be 120 kg into 50, which is nothing but 600 kg meter per second. So the impact we can observe here is little bit when I compare to the bus now. So bus will be going with 50 meter per second only, but the mass has been increased. So mass of the scooter is 120, but the mass of the bus will be same, it will not be same as 120, no? So it is 700 kg. So 700 into 50 is nothing but 35,000 kg meter per second. So if I go with a scooter and if I hit a man, he will get some scratches. But if we go with a bus and if I hit a man, what will happen? He will die on the spot, na? That's it, no? So wherever we go, we should go slowly. Okay, that's the thing we can learn here. So impact on the wall is higher in case of bus and its momentum is higher, right? You can take a note of this momentum. Sir, can you explain again? Yes, I'll explain. See, momentum is nothing but it's a product of mass and velocity. Okay, so when I talk about SI unit of mass, no, it is kg. So kg, and SI unit of velocity is meter per second. So SI unit will be kg meter per second, and it is a vector quantity, we'll say. And what is the point we can notice here is when mass increases, momentum increases. When velocity increases, momentum increases. If it decreases, momentum also decreases. So that's what example we have seen here. Okay. So we have compared two examples between the scooter and the bus going with the same velocities, but they are having the different masses. So different masses in the sense like mass increases, momentum increases, right? So when I talk about the momentum for the scooter, it is 120 kg into 50 meter per second. So we got 600 kg meter per second. But we talk about the momentum of the bus, no, it is 700 kg into 50 meter per second, which is nothing but 35,000 kg meter per second. So the impact will be more for the bus. So here it is 600, it is 35,000. So obviously it is more, no? Okay. I hope you got the point now about the momentum. Yes. So now another example we'll take. So the greater change in momentum in given time, the greater its force that needed to apply. So for example, a bullet is going with high speed, which means if it hits the target, no, it will reach the maximum distance or displacement, whatever it is. Now the moderate speed it is going, which means it cannot penetrate more, no. When I am going with more speed and if I hit something, it will go some maximum distance. But if I go like this and if I hit like this, what will happen? It will not even move, no? Yes, no? So if a heavy weight man is there, okay, if I want to push him, okay, I am having a mass is 70, his mass is 140. If I want to push him like this, I can't. But if I go back somewhat, I apply some velocity, if I come and if I push him, what will happen? He will try to move. He will not fall. I will only fall. But he will try to move. Yes or no? So the same condition here, no? It is going with speed. So it will penetrate more. It is less speed. It will penetrate less. Okay? So one more example we'll take here. So cricketer allows a longer time for his hand to stop the ball. So we have seen, no, when the players used to catch the ball, they won't catch like this. They will take time to catch. Yes, no, they will take time to catch. Like if they will keep the hand like this and they will take the hand back towards back. So he draws in the hands backward in the act of catching the ball. So on the other hand, keeps his hand fixed and tries to catch the ball almost instantly, which means he needs to provide some much greater force to stop the ball instantly, and this is the hurt. Like when I try to catch, no, simply if I try to catch, what will happen? I will get hurt. If I try to catch the ball like this, no, what will happen? I am taking some time to catch it. Yes or no? I stop the ball, but I have taken time to catch it. So which means if I take a long time, the hurt will be less. If time is less, I get hurt. Yes, no? Okay. Force not only depends on the change in momentum, but also how fast the change in brought also. Okay, about the time also. So the same change in momentum brought about in a scooter time needs a greater applied force. The same force for the same time causes the same change in momentum for different bodies also. Okay, so when we compare the different bodies, the different momentum will be there. Okay, done. So now we have completed the momentum topics and the free body diagrams of the normal, tension and the weight also. Okay, so Newton's first law also completed, law of inertia. Now we will go for the Newton's second law. Okay, so Newton's second law states that the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. So what we called momentum? Momentum is nothing but mass into velocity. Rate of change of momentum is directly proportional, no? So rate of change of momentum is nothing but dp by dt, like momentum with respect to time. Okay, should be equals to, like mass will be constant, right? Will mass change? No, only the velocity changes. So with respect to velocity I will take, right? No, so dp by dt is equals to mass into dv by dt. What is dv by dt called? It is acceleration of velocity by time. And what they have told, rate of change of momentum of a body directly proportional to the applied force. So dp by dt will be force, no? Which means dp will be equals to f into dt, no? Yes, no? So we have seen one example, right? Catching a ball to take long time. So if time is greater, momentum will be So the force will be less. If time is greater, force will be less. No, time is greater. What will be the force? Will be less. Which means force is inversely proportional to the time. No. If I take more time, the force which is acting by the ball will be less on my hand. If I take a less time, the force which is acting on my hand will be more. That's why we are getting hurt. Okay. So dp by dt will be mass into acceleration, which is nothing but force will be equals to mass into acceleration. This is my formula for the force. I can take it down. So I will give the equation here to write it. Okay. So force will be directly proportional to rate of change of momentum with respect to time, which is nothing but F is equals to remove the proportionality, I am adding a constant K. So will be equals to delta P by delta T. Okay. So we have got the equation F is equals to ma. So what will be the SI unit of the force now? Mass is nothing but kg, acceleration is meter per second square. So kg meter per second square will be my SI unit, or else I can say it is a Newton. Okay. 1 Newton is the force that causes an acceleration of 1 meter per second square to the mass of 1 kg. You can take a point of this. Done. So next one is some important points about the second law. Like in the second law, F is equals to 0 implies acceleration will be 0. So if acceleration is 0 means force will be 0, no? So F is equals to ma, where if a will be equals to 0, obviously the force also will be equals to 0. So second law is a consistent with the first law. So force is always parallel or anti-parallel to the velocity of a body. Okay. So if I talk about like Fx and Fy and Fz, like force in x-axis, force in y-axis and force in z-axis, okay, which is nothing but momentum with respect to time, no, in x-axis, y-axis, z-axis. So mass into acceleration of x-axis, y-axis and z-axis. So what they are saying, force is always parallel or anti-parallel. So a force is acting towards down, it's a projectile motion now. So projectile motion means this is the object, I have projected with some velocity v, having an angle theta over here. Okay. So if angle theta means I should take the component now here, which is my velocity x and this is my velocity y, direction x, I mean x direction, y direction. So similarly, if in every point it will be x and y, no? Yes, no. So if I see here, the velocity is perpendicular, force is there, velocity of x axis will be perpendicular, no? Y axis will be parallel, no? Or anti-parallel, no? Parallel or anti-parallel, right, no? So anti-parallel. So y axis will be anti-parallel, x axis will be perpendicular. So it can be parallel or anti-parallel of the velocity of the body. Okay. So if I see here, Vx is perpendicular to F and Vx remains constant. So wherever if I go, Vx will be remains constant, but Vy will be changes. It can be parallel or anti-parallel also. Yes, no? So in this case it is okay. If I come here in this case, no, velocity y will be in this direction and x will be in this direction. So which means both are parallel. Yes, no? In this case it is anti-parallel. Up to this case, again up to here it is parallel. Okay, you can take a point of this. Done? Okay. Okay. So the motion of a particle, here is the question. Okay. The motion of a particle of a mass is described, wait a minute, described by y is equals to ut plus of at square. Find the force acting on the particle. Okay. So here what is the equation given? Y is equals to ut plus of gt square, right? No, gt square. Now we know that having a mass m, let me consider. Okay. And what is the equation given? The displacement equation is given. No, s is equals to ut plus of at square. What is the equation? This is displacement, right? If I differentiate with respect to time, what will happen? Velocity will get, no? This side if I differentiate with respect to time, and this side also if I differentiate with respect to time, I will get my velocity, right? No, so which is nothing but ds by dt will be equals to, yes, no, I will get my velocity equation. So differentiated. So differentiate means, let me consider this is v, velocity will be equals to, what will happen here? U plus 1 by 2 into gt. Yes, no? Half is constant, g is also constant. So t square will become 2t, t will become t only. What is the formula? X power n is nothing but n into x power n minus 1, no differentiation. So what will happen again if I want acceleration? Again differentiate with respect to time, which is nothing but a will be equals to 0 plus 2 will get cancelled, g into 1, which is nothing but a will be equals to g only, right? No. So find the force acting on a particle, which is nothing but F is equals to mass into gravity. That's it. Done. Can we go for the next one? Okay. Now here is the equation. Before that, we will see one more point here. Second law of a motion is applicable to a single point particle. So, if F is a net external force acting on a particle and acceleration A stands for, A stands for the acceleration of the particle or center of mass of the system. So, any internal force in the system are not to be included in F. If F is there, the total object will be acting at the center of mass, which is nothing but acceleration. Yes, no, that is what they are saying. No, if F is the net external force acting on a particle and A stands for the acceleration of a particle or center of mass of the system. So, remaining whatever the internal forces are acting, no, internal forces in the system are not to be included in F. Okay. So, internal force is different, whatever the external force is applied is different. Okay. Now, here is the question. A bullet of mass 0.04 kg moving with a speed of 90 meter per second. I will write the given things here. So, mass is 0.04 kg moving with the speed of 90 meter per second, enters a heavy wooden block and it stopped after a distance of 60 centimeter. So, a displacement happened is 60 centimeter. I need to convert it to meter. No, everything a SI unit. So, what will be the meter? 60 into 10 power minus 2, right now, which is nothing but 0.6 meter. What is the average resistive force exerted by the block on the bullet? I need to find this one, right now. So, stopped in the sense initially velocity was 90. So, at stop means final velocity will be equals to 0. So, find the acceleration and I can find the force here. So, which means I can use the kinematic equations. What is the kinematic equations? V is equals to U plus AT, V square minus U square is equals to 2AS, S is equals to UT plus of AT square. In this first equation, if I see T is there, in this given T is not there. So, I can eliminate this one. Second equation, V is there, U is there, S is there. So, I can use this one no directly. So, which means V is 0 square minus 0.6 no, 0.6 the whole square should be equals to 2 times acceleration. This one is velocity, no, 90 square I should take. So, 0 square minus 90 square is equals to 2 into A into 0.6, right? That is it, no. So, from this I can find what is the acceleration. So, if I find acceleration, what they are asking? Resistive force. Resistive force in the sense I am opposing the bullet. Okay. So, which means I need to find F is equals to ma. So, you will get force in terms of negative because acceleration will be in terms of negative. So, force in terms of negative means I am opposing the force, that is it, meaning. So, I should get no. So, this one will be eliminated. So, 9 into 9, 81, right now. So, 8100 will be equals to 1.2 A, that is it, no. So, from this I can find what is A. I can substitute the value of A in this case, mass we know, that is it. So, find F and give me the answer. So, whoever watching in online no can give answer in comment boxes, we will check it. So, with this we will stop the class, okay. We will see the next upcoming topics in the next classes, okay. Bye guys, we will meet in the next class.